Hello friends, welcome to Truth of Physics. Today in this video I will discuss the analogy between Stern-Gerlach experiment and polarization. Previously I made a video on sequential Stern-Gerlach experiment and that video is very much helpful to understand this video. So here is the slide of the previous video. There I have discussed that any measurement, not exactly any, the measurement for two observables that are non-commutable, okay, like this. Their commutation, if two observables or if we measure sx and z, for example, this sx and sz, we know that the commutation of these two is not equals to 0. For this kind of thing, we have discussed that for this kind of two observables, when we measure any one, then the previous information of measurement of the other will be lost. There I have discussed that like this, when we apply the beam in through the SGZ component and block this SGZ minus block this SZ minus component, there is only present the SZ plus component. But after we measure the X component of that beam, then we get again the two components, SS plus and SS minus. But after that, when we again measure the Z component, then we get again the SZ minus component, but we have blocked that previously. Now this is a property of quantum mechanics. We have discussed that of non-commutable or incompatible observables, but we can understand it physically using the analogy of Stern-Gerlach experiment with the classical concept of polarization of light. Now, what is the polarization of light? Briefly, I can discuss it like this. Polarization of light means light have, suppose light is coming from this direction, coming in this direction. So, in any particular point, the electric field vibration is in all directions, right? But if now we apply or we put some kind of filter where we have only the pass axis in the y-axis and pass this light through it, then after that we will get what? We will get the light beam of only electric field vibration in this direction, because we are passing only these fields, right? The other fields will be just blocked. So that concept is here introduced. Like if we have a X component filter, okay, X component polarizer. Now if you want to understand polarization of light detailedly, I have made a dedicated video. You may watch that video. The link I will give in the description box. Now if we pass a non-polarized or unpolarized light through this X filter, then obviously we get 100% X polarized light, means the vibrations are only in X direction electric field. There is no Y component because X and Y component are 90 degree, right? And from the concept of vector, we know that any vector don't have any component along its perpendicular, right? So there is no Y component present in this beam of light. But after that, okay, now if we after applying X filter, if we apply Y filter, right, there is only X component, there is no Y component. Now if we apply Y component, obviously we get no result or we get no light after that, because there is no component in this direction. This light have no component perpendicular, and there in this filter only we have pass axis in the perpendicular direction. So obviously, as there is no component perpendicular, so we will get nothing. All the lights will be blocked, so we'll get nothing. But if we introduce another filter X dash, which is 45 degree angle with the X axis, means which is at angle like this, 45 degree, this angle is 45 degree, then what happens? Then we can see that this beam will pass through it, and there will be this is the pass axis of this beam. So the beams will be like this right now, because this beam here, the beam was this, right? So this don't have any perpendicular direction component, but it have 45 degree component, right? And that 45-degree component will be passed through first after this filter, and that is like this. Now this each component have, if we divided components, right, vector components, then we can get again x and y components, right? So after that, when we measure or when we apply the y filter, then we will get y component light or y light with y direction vibration. Now you can mathematically understand it. Now you may understand these two mathematical results from your concept of electromagnetism, that any light beam, we can express the electric field component of any light beam whose electric field is along the x dash, means 45-degree diagonal, can be expressed as a linear combination of x component and y component. Means this can, you can understand like the classical vector or unit vector like r cap and theta cap in your curvilinear coordinates. Like r cap can be expressed like cos theta plus I sin theta is cos theta plus I sin theta, and another is, and the theta cap can be, which r cap is like this and theta cap is like this, right, and this like this. So that theta cap can be expressed like cos theta minus I sin theta. So you may understand this thing with that thing. I will discuss that pictorially right now. Now you may think, right, this figure, from this figure, the x component, initially we have what, the x component light, right? Initially we have only the x filter, means this light here this light is only x component, the presence there is only x component present in that light. So this x component light, now we can divide it into two components like this. One is in this direction, which is nothing but our 45-degree x dash, and another is like this. This is what, negative of y dash. So we can express this x dash x component in terms of, or in, with the linear combination of this and this, right? Like if we think it theta, then cos theta plus I sin theta, or this kind of things. You may understand this. Or, and after that, what we did, after that we placed an x component filter, right? And that makes the beam in the x component, right? So this beam becomes now x component. After that, what we did, right, this beam, the beam here is the x component beam, means this beam. Now this x component can be divided into two components, this and this. So this x dash can be divided into this and this. Now if this angle is theta, now you may understand that this x dash can be written like cos theta. Theta is 45-degree, cos 45 plus I sin 45, right? Means what, cos 45 is 1 by root 2 plus 1 by root 2 into that component, plus I just remove, and sin 45 is again 1 by root 2, so into that component. So 1 by root 2 into some component plus 1 by root 2 into some component. And the y dash can also be divided into two components, like the perpendicular and in this direction. This is what, this direction is what, negative of x cap, right? Now so we can express y dash as cos 45 minus I sin 45, means 1 by root 2 into something minus 1 by root 2 into something means 1 by root 2 into y cap, right? Y cap into minus 1 by root 2 into x cap into something, and that I have discussed, that I have written here. Here x component is 1 by root 2 into something along the x component, and 1 plus 1 by root 2 into something along the y component, and y dash 1 by root 2 into y component into some component into y cap, minus x cap into 1 by root 2 into some component, like this. So it is justified. Now just make an analogy of the Stern-Gerlach experiment with this thing. Just try to make analogy with SZ component with the x and y polarized light, and the Sx plus minus Sx plus minus component with the x dash and y dash polarized. Then what happens? You can understand that now what we have discussed here, that first we pass the sz component. Sz component means here what xy polarized, means we pass here the x, right? The x polarized light means the x filter we pass first. The x filter means the x component light, that is equivalent to the sgz, means these are x component light. Now what happens? We have blocked this thing, means this is this you can think like the y component is blocked, just blocked. Now this sz plus beam is passed through sx, and what we have we can think of it, sx means sx is s dash and y dash polarized, mean this thing, this thing, this thing. So it have the components, it already sz plus have already component of sx, and when we pass through this ss, then the ss component is passed out, and that is this ss plus and ss minus. We block this component, and each of this component ss plus and ss minus have already components of what? Components of sz, right? Az means this y, it already have the y, means when we divide this, that means these components, after the division, this component already have the component of y, means here is z minus component. And that is usual, that after that when we put the polarizer, right, then we will get the sz component also. Now just understand it with here. First we have sz, right, but that sz, after the sz passing or we block the y component or the sz minus component, right, means there is no y component, only x component, means sz minus component. Now this component can be divided into two, this and this, and you understand that this, when we divide this in twos, then already in each of these twos, for example in this component already exists this and this, because this is nothing but a combination of this and this, right? So after, so what is mean by this division? Division means that when we put the second sgx cap component, means we are dividing this beam into two, right, x dash and y dash, and each of these x dash consists of y component, means sz minus component. So after that, after the measurement of sgx cap, when we measure again the sgz cap, yes, obviously there will be the szz component, because after this measurement we what we get have already the components of the z component, and we are just selecting that thing. So I think you may understand this concept of the analogy with polarization and the sequential standard Gerlach experiment. If you have any doubt, then you can comment below, and I hope that you have enjoyed this video. Share this video with your friends and take care of yourself. Thanks for watching.